Hi, in this video we're looking at the trapezium rule. Now, the trapezium rule is a way in which we can try and find the area underneath a curve by splitting up the area into a collection of trapezia, hollow trapeziums next to one another. It's an inexact way of being able to get to an area, but it will give you at least an approximate answer to the area. So let's consider the definite integral of x squared between 1 and 4 dx. If we think about this graphically, I'll need a pen there, we're going to have our curve going something like this. And for argument's sake, let's say that this is the point where x is 1, and this is going to be the point where x is equal to 4. And we want to find the area underneath that curve. We want to find this shape in here, that space in there. Now, what we can do is we can split this up into different trapeziums. So I'm going to split over here at 2 and 3. So that's 2 and that's 3. What I'm going to do is I'm going to draw a line from there up to the graph. I'm going to draw a line from there up to the graph. And then I'm going to create trapeziums, 3 of them in total. So I'm going to call that area 1, area 2, area 3. So obviously this is not going to be exact because, and if I go and just expand this area over here, I'm going to have the curve going like that. And then the line is going to be going over the top of it. And there's going to be a bit of missed space underneath there. But I don't worry about that at this stage because this is going to be an approximation, not an exact calculation. So what I need to do if I want to work out the area of that trapezium is I need to know the length of the parallel sides. In other words, the lengths of these red lines along here. So to do that, I'm going to have to look at my function. The function is basically f of x is equal to x squared. So f of 1 is going to be 1 because 1 squared is 1. F of 2 is going to be 4. So in other words, this value over here is 1. That value over there is 4. F of 3, well, that value over there is 9, because 3 squared is 9. And f of 4 is going to be 16. That value over there is 16. And all I need to do now, if I want to find my total area, is that I need to sum these up. So my area is going to be trapezium 1 plus trapezium 2 plus trapezium 3. And if you remember, the area of a trapezium is half the sum of the parallel sides times by the height, the distance between them. The distance between them, this green part over here, is that gap there. The parallel sides are the 2 red lines that we've got drawn there. So for trapezium 1, it's going to be a half of the 2 parallel sides are 1 plus 4. And the height is going to be 1. For trapezium 2, it's going to be a half of 4 plus 9. And the height between them is 1. And for trapezia 3, it's going to be a half of 9 plus 16. And the gap between them is 1. Now that you've got those calculations set out, we can now go and figure out what we've got here. We've got 5 over 2 plus 13 over 2 plus 25 over 2. And in total, that's going to give us 25 and 5 makes 30. It's going to give me 43 over 2, which is basically 21 and a half. Isn't it? 21 and a half, yeah. So that's the area. Now, if we went, and we can go and do this as a definite integral because it's an easy enough integral to be able to work out, between 1 and 4 of x squared dx. Well, that's going to give me x becomes x cubed, and I'm going to put it over 3, and it's going to be between 1 and 4. So I'm going to have 4 cubed over 3 minus 1 cubed over 3. That's going to give me 64 minus 1 all over 3. In other words, 63 over 3. 63 over 3 is 21. So that's the exact area. This is my approximate area. And the reason why it's an approximate area is because we have been overestimating this area over here. As I tried to show to you earlier, our curve is going like that. I'm going to exaggerate this slightly. And the line of the trapezium is going like that. So when I work out this area here, I'm actually working out more than the area underneath the curve. Had the curve been slightly different, had the curve been a curve that went like that, and my trapezium was going to be going there, then I would have worked out the area of the trapezium, and that would be an underestimate of the area under the curve. But again, it would be close enough for the purposes of the approximations we wanted to make. Now, you can split that up into as many or as few trapeziums as you want to. Obviously, the more trapeziums that you have, the more accurate you're going to be with your approximation. When they set a question like this in the exams, they normally give you three or four regions to do. They don't expect you to do a whole lot more than that, because if you can do the area calculation once, you can do it a lot. You don't need to do it 7 or 8 or 9 times just to be a little bit more accurate. Now, there is a formula that you will find on the formula sheet for this and in your book. I don't use it because I think it just becomes a little bit more complicated than it needs to be. I think what you need to understand fully is how the trapezium rule works. Basically, it splits the area under the curve into a set of adjacent trapezia, and you're finding out the area of each of those trapeziums. What you need to go and do now is to go and practice those. Good luck. Goodbye.